Okay, find non-permissible values and solve. I'm going to solve it first and I'll knock off the non-permissibles at the end, just in case we get more than one denominator on our way through here. Okay, there are two ways you can approach these. One of these is called cross multiplication, which works great, which says that if you have two rational expressions that are equal, you can multiply the two on opposite corners like this, and multiply the two which are on opposite corners like this, and those products should be equal. There's another way which involves common denominators, which I'm going to use in question B, but for this one I'll use cross multiplication. So if you cross multiply, you get that 4x minus 2 times 3x plus 5 is equal to, now going the other way, 2x plus 3 times 6x minus 1. If there were anything I could cancel here, I would gladly go for it, but there is not, although I could factor a 2 out of there, I suppose. I don't think I'll bother. I'll just expand this, and there might be a factor of 2 later I'll have to worry about. If I FOIL both of these, I'll get a pair of quadratics. I can combine them into one quadratic, and then we'll see where we can go from there. So first, 4x times 3x. Outside, 4x times 5. Inside, minus 2 times 3x. Last, minus 2 times 5. Equals, first, 2x times 6x. Outside, 2x times negative 1. Inside, 3 times 6x. And last, 3 times negative 1. Now, I'll combine like terms before we go on. I want to make this smaller as soon as possible because I'm eating into the space I'll have available for B. 12x squared. 20 minus 6 is 14x. Minus 10 equals 12x squared. Minus 2 plus 18 is plus 16x minus 3. That's a little better. Now, we'll take everything over to the left-hand side. A really nice thing happens here. 12x squared minus 12x squared is just gone, so this won't even be a quadratic. I thought it was going to be, but the fact that these coefficients match is really quite nice. Then we get, so I did 12x squared minus 12x squared. Then we have 14x minus 16x gives minus 2x. And minus 10 plus 3 leaves us with minus 7 equals 0. Well, now that this isn't a quadratic, my idea about making it equal to 0 doesn't look so clever, but no big deal. We can change now. I'll take the 7 back over to the right. Minus 2x equals 7. Divide by negative 2, and you get x equals minus 7 over 2, or minus 3.5. So just one solution, it looks like. What are our non-permissible values? We had 2x plus 3, which can't equal 0, or else we'd get a division by 0 problem. Solve that, and you get x cannot be minus 3 over 2. And the other one would be 3x plus 5. That also cannot equal 0, which means x cannot be minus 5/3. All right. So this is our solution. It is a permissible value. It isn't one of these no-go numbers. So it's valid, and we can go on to the next one. Now here, it's a good thing I did cross multiplication for the first question because I couldn't use it here. Cross multiplication only works when you have exactly two rational expressions, one on each side of the equals. Here we have two rational expressions, and then we have a third one. And I'm making that into a fraction just by putting a 1 under it. So the way you'd have to deal with this is by common denominator. We have to multiply every one of these things by the common denominator, which is t plus 1, t minus 3. I don't think I can fit it in legibly with the space that I have, so I'm going to write this thing out a little bigger, first of all. No changes, just a recopy. 5t minus 2 over t plus 1. Leave some room. And then 2t minus 1 over t minus 3. leave some room, equals 3 over 1. That's still not a ton of space, but it should be better at least. So our common denominator is t plus 1, t minus 3. The first term gets both of those things, and that should be bracketed as well. The second term gets a t plus 1, t minus 3, and the final term gets a t plus 1 and a t minus 3. So what happens? In the first term, the t plus 1's cancel out. In the second term, the t minus 3's cancel out. In the third term, nothing cancels out, unfortunately. So we're left with this. 5t minus 2t minus 3 from our first term, minus, then we have 2t minus 1 and t plus 1. And on the right we have 3 and t plus 1 and t minus 3. No obvious cancellations or anything, so now I'm going to expand it all, collect terms on the left, and again I'm just going to assume that this will give a quadratic. If it doesn't, that'll be a lovely surprise, but if it's a quadratic, I'll want it to be t squareds and then t's and then numbers equals 0, and then we'll either try to factor it or we'll do some other clever quadratic thing to it. 5t times t is 5t squared, that's first. Outside minus 15t, inside minus 2t, last plus 6. Now minus, watch out, this minus sign applies to everything that we're about to write. I'm going to use square brackets to hold all of the stuff from here. 2t times t, outside is 2t, inside is minus t, last is minus 1, equals 3, we'll worry about that in a moment, t squared minus 3t plus t minus 3. Okay. This minus right here has to distribute through all of those terms. This 3 has to distribute through all the terms on the right, so we'll get that done, and then we can finally start collecting. 5t squared minus 15t minus 2t plus 6 minus 2t squared minus 2t, this is coming out of these square brackets, plus t, minus times minus, and then minus times minus again gives plus 1. And on the right, 3t squared minus 9t plus 3t minus 9. 1 equals in the center. And now we take everything over to the left-hand side. So 5t squared minus 2t squared, so 3t squared's left. Then this comes over and becomes negative. No t squared's left. It happened again. The t squared's canceled out. Very nice. T's, minus 15t, minus another 2 is minus 17t, and another 2 takes us to minus 19t. Up 1, we're at minus 18t. This becomes plus 9, so now we're at minus 9t, and then we lose 3 when this comes over to the other side, so minus 12t if I'm not mistaken. And for plain old numbers, we have 6, plus 1 is 7, plus 9 is 16. Take the 12t to the right-hand side. 16 equals 12t. Divide by 12. T is 16 over 12. But wait, that fraction reduces. It's actually 4/3. So there's our solution. Now, denominators. We had t plus 1, which must not be 0, so t can't be negative 1. We also have t minus 3, which can't equal 0. And so t is also forbidden to be 3. That's a plus 1, and this was minus 3, yeah. So again, two non-permissible values, but our solution isn't either of them, so our solution is all right.